Hi guys, my name is Avinash Kumar. Welcome back to my channel Stochastic Programming. In this video we will talk about the new features and the new updates which are released with JDK 15. Last week we covered about the different categories on the basis of which JDK folks release these new features. If you haven't watched that video, I have put a link in the description. It would be easy for you to understand what are the, on the which basis JDK folks release those features. So without further ado, let's get started. So the first enhancement proposal covers the implementation of a digital signature, which is based on the Edward curve digital signature algorithm. There is already one implementation exists, which is called the elliptic curve digital signature, which is written on top of, I believe, C language, and in this JEP or in this enhancement claims are the new algorithm will perform better compared to the existing one. So the next enhancement proposal is tied with Java classes. So there is a new concept coming in with JDK 15 regarding the sealed classes. So what are the sealed classes exactly, and what are the benefits associated with the sealed classes is the question, right? So currently, as an application developer, if I have written a class and I don't want other classes to extend my class, what can I do? Well, one possible approach which I can think of is I'll declare it as a final class so that all the other classes won't be able to extend my class. Cool, fine. We can do that. Perfect. Now let's say the requirements are changed and I want to allow some classes to extend my class, but I still don't want other rest of the classes to extend my class. What can I do? Well, there is solution exists for that as well. I can make constructor package private class, which means classes within that package will be able to access and extend my class. Not access, obviously other classes can access using the getters. Here we are talking about the inheritance, which means the classes which are part of the same package would be able to extend that class. Fine. Now let's say the requirement is changed and I want to allow classes which are even outside of the package. I want to allow them to extend my class, and there are some classes within the package and I don't want to allow them. So prior to JDK 15, we cannot do that. I mean, there is no possible way which I can think of. So in JDK 15, this concept of sealed classes helps us to control our classes or interfaces even. So with that, all the classes which you want to allow or which you want to permit to extend your class or interface, you can do that. So when declaring the class, you will define what classes you want to extend. Let's say if I have a class called shape, I want to allow square, circle, and rectangle to extend this class, but I don't want to allow, let's say, line. Though line is a shape, but just consider this example. I want to allow these classes to extend. So what I'll do is I'll mention these classes when declaring the class or the interface, and those classes would be able to access even they are outside of the package. So this is actually cool if we think about abstraction. So this helps us to control our classes more in a better way. So the next enhancement proposal is JEP 371, and this is mainly for the framework developers, because let's say if you are working for working in a Spring team, or people who are managing a Spring Boot framework or any other framework, let's say Hibernate or Structs, and now you have written classes and you don't want your other developers who are using Spring Boot or Hibernate, you don't want them to use or access your classes by any way. So currently, even if you have make your classes as private or whatever final, using reflection API, we can, as a developer, we can access those classes, right? And as a developer, and as a framework developer, I don't want programmers to access my class. So these are more like a non-discoverable classes, where the framework developers wants to hide the implementation details. It can be because of the security reasons and other. And so these classes cannot be linked against other classes. So, and nor you can discover it by any means of, reflection API or some other way. So this is interesting one. So the next enhancement proposal is related to JavaScript. So in JDK 15, JDK folks have removed Nashorn JavaScript engine. It was first deprecated in JDK 11, and now even the code is removed. So if you are even using now and you have plans to update your application with JDK 15, so it won't compile, and even with flags you won't be able to compile your code. So because the code itself is removed. So why is that? I mean, they have removed this thing. um, well, the one possible reason, I mean, it's not the possible reason, it is actually the reason is JavaScript. If you see, the JavaScript construct is changing rapidly. I mean, all the APIs and all the framework libraries, they are changing rapidly. So from the perspective of JDK folks, it is difficult and challenging to, uh, maintain and provide updates with respect to the JavaScript engine. So which is why now this thing is removed completely. So the next enhancement proposal is related to DatagramSocket API. So this JEP covers re-implementation of legacy DatagramSocket API. The aim is actually to replace the existing implementation of Java DatagramSocket or the multi-socket API with the updated version. And there are possible reasons why they want to re-implement this API. The first thing first is um, these APIs are coming from JDK 1.0, which means the native code is written in C or maybe some code in Java as well. So which is difficult to maintain and debug. So this new implementation will make things easier for the OpenJDK folks. Also on top of that, there are some issues with the old APIs as well related to the synchronization when you have multiple threads. So there are some corner cases where the API will not provide the expected behavior. So the new implementation will actually address those issues as well. Also on top of that, since it's really a old code, so they are not removing the legacy code right away. So with the command line flags, you will be able to switch between the legacy implementation and the new implementation. So the next enhancement proposal is related to the bias locking. So in JDK 15, bias locking is disabled by default and it's deprecated. Why is that? What is bias locking at first place? Well, let's say if your application supports multiple thread, you have a shared resource. In order to access that shared resource, you will provide some locking mechanism, right? And when if a thread wants to access that shared resource, thread will first get the lock and access that resource. Now, if you see here in this design, that shared resource is actually biased towards that thread who have access on the lock, right? Now, this design is actually not good in the longer run when you will scale your application horizontally. Why is that? Now, to understand this, let me give you an example. Let's say you have opened a new business which provide printing and designing services, and you have hired some workers. So here workers in our case is, the number of threads, right? So because you have recently opened the new business, you have only one printer and multiple workers who will actually serve customers' requests, right? So in order to avoid the busy waiting, what you have did is you have informed your developers that this is the key and the printer is exist in the room. In order to access the printer, you need to open that door and you need to access that printer, right? So if the key is not available in the table, it means you should focus on the design rather than printer, because printer is already occupied by some other worker, right? So far so good. Okay, developer or the designer will come, check the key. Yeah, key is not accessed. Developer will either wait or go again and focus on the design work and complete design for the other customers, and he will print later. Fine. Now let's say your customers are increasing, so you have put one more printer, or you have put let's say five more printers. Now here if you see, the problem is even in that room there are five printers, but you have only one key. So whenever the first developer will go and access the printer, other developers will come and getting this impression that all these printers are occupied by some other workers. This is not the good approach. Similarly, in case of the software, let's say in that shared resource, since now you're scaling your application horizontally, you have more containers or you have more virtual machines to execute your application. So you want to allow at least, let's say, four threads to access the resource. This locking mechanism will force you to change every time code whenever you are adding a new resource, right? So this is not a good approach. So the better approach is, you should use either the thread pool architecture or the worker queue. So every time, when you increase the resources or when you scale your resources horizontally, you just need to increase the thread pool size, or the, in case of the worker queue, you will just increase the number of workers. So this is actually the good approach, right? So which is why this feature is actually disabled and deprecated. I hope this will explain the reason why is that. So the next enhancement proposal is related to pattern matching for instance of operators. So this this particular feature was released initially with JDK 14, and now again it is released with JDK 15 as a second preview. I have already covered this feature in detail in one of my video. I'll provide the link in the description. Um, in this particular JEP, they haven't made any changes, or they haven't provided any new features in contrast with this JEP. So we'll move on the next one, which is the JEP 377. So this is regarding the Z garbage collector. So this is a scalable low latency garbage collector, which was first introduced in JDK 11 as an experimental feature. So in our last video, we discussed what are the experimental features, and so they are tied mostly with the hotspot JVM. So they don't release entirely in one go. They release incrementally. So when they released with JDK 15, it was only available for Linux x64. Now in this release, it's available for all the common platforms: Windows, Linux, Mac OS, and other. So I was thinking that might be because Z garbage collector, its performance is good. They might make it as a default in JDK 15, but still G1 is the default garbage collector of this release. So the next enhancement proposal is related to text blocks, JEP 378. Again, I have discussed this JEP or this feature in detail in my in one of my video regarding the OpenJDK 14. I'll provide link in the description. So this particular JEP was actually released in JDK 13, and in JDK 14 it was released as a preview category. I believe it was second preview for this feature, but now after getting the feedback from the community, OpenJDK folks have released this as a final and a permanent release with JDK 15. So in order to use this feature, you don't need to provide additional flags or anything. It's by default enabled. It's implicit. If you are using in JDK 15, you won't get any warnings or anything. That's cool. The next enhancement proposal is related again with garbage collection, and this is JEP 379, Shenandoah, a low time pause garbage collector. Initially, when it was released with JDK 12, it was released as an experimental feature, obviously. Now in JDK 15, it is released as a standard production feature. So if you're using now, you will not get any warnings or any other things. But again, since G1 is the default garbage collector, as I mentioned earlier, you need to provide extra flags to access that. So the next is JEP 381, removal of Solaris and Spark port. So if you're not aware what is Solaris or Spark, so Solaris is instruction set architecture, and Spark is a Unix-based operating system. So it was so they both were initially developed and managed under Sun Microsystems, but when Oracle acquires Sun, um, in 2017 they ditched both these systems, though they are still providing the support, and I guess they'll provide support up till 2034, but obviously the plans are to retire these two systems, so which is why in JEP 381 they are removing the support for the Solaris and Spark ports. And in JDK 14, they depreciate initially, and now even the code base is removed, just like the Nashorn JavaScript engine. So the next enhancement proposal is related to foreign memory API access. So this API particularly will allow Java programs to safely and efficiently access foreign memory outside of the JVM heap. So in general, obviously the goal is to introduce, a single API which should be operate on various kind of memory, whether it's a native memory or persistent memory or managed heap memory, etc. So provided that it should not be possible for the API to compromise the safety of the JVM itself, regardless of the kind of the memory that the program wants to use. Other important thing, is regarding the deallocation. So unlike C++ developer, we as a Java developer have this luxury that whenever we declare any memory, we don't need to worry about the deallocation. Java garbage collector, does this job for us. So, but when we talk about the foreign memory access, being as a developer, it's our responsibility to deallocate that memory which we have allocated, because the garbage collector won't be able to access that memory. So it's the developer's responsibility to deallocate that memory. So this API provides all this functionality regarding the allocation and deallocation. And so prior to JDK 15, if you want to access the foreign memory, there is already a legacy API, Java API available, which is called, sun misc unsafe. So if you want to access prior to Java 15, you can use this API to allocate memory on the foreign memory. So the next enhancement proposal is again tied with Java classes, and this is called records, and this is released as a preview, second preview feature in JDK 15, and in JDK 14 it was released as a first preview, which is why we have already covered this feature. If you haven't watched that video, I have again provided link in the description. It would be easy for you to get more information from that. The next enhancement proposal is related to JEP 385, depreciate RMI activation for removal. So what exactly is RMI? So RMI stands for remote method invocation, which is equivalent to RPC, which we used in C language. Again, what is RPC? This is remote procedure call. Let's say you have a process running either a local or a remote machine, and you want to call particular function in that process, right? So with RPC we can achieve this goal. RMI is actually implementation on top of the RPC, which supports object-oriented paradigm as well. So it is easy. Being as a Java developer, you will access RMI and execute that function on the other process, right? So far so good. Now if we see why they have obsolete this particular activation API here in JDK 15. Well, there are various reasons. One possible reason is if we see in the last decade in distributed systems, we don't really use RMI or remote procedure calls, because whenever the communication is required, we either go for WebSockets or RESTful communication, right? there is no significant use of RMI, which is why in JDK 15 they have deprecated this, and in coming release they'll remove the code base as well. Because obviously, things which are not used and which are exist in Java, maintenance requires cost. So just to avoid that cost and support productivity, they are removing all these functionalities we saw in Solaris and in the Nashorn as well. So this is the actual reason. So this is all from this video. I hope you like this video. Please like, share, and subscribe to my channel if you haven't done that yet, and don't forget to press the bell icon. Thank you.